Scaling sound. This activity is designed to help strengthen your understanding of logarithmic scales. It involves working with decibels. Recall that the decibel rating of a sound is 10 log I over I sub 0, where I is the intensity of the sound and I sub 0 is around 10 to the minus 16 watts per square centimeter is the reference intensity. I sub 0 is just a constant. So I'm warning you here that this is a very challenging activity. So hopefully you are patient with yourself and you work through it. Even with watching this video, it's still going to be tricky. So really, you're going to puzzle through these concepts. Expect it to take some time to digest the ideas here. Number one, the buzz of a nearby mosquito produces a sound with intensity of about 10 to the minus 12 watts per square centimeter. What would the decibel rating of the mosquito's buzz be? So the decibel rating is just given by that formula right there. So we just have to plug in. Number of decibels is 10 to the log of the intensity is given in the problem as 10 to the minus 12, divided by I sub 0 is always 10 to the minus 16th. It's always, always, always that. And so we're just going to crunch through the numbers here. Okay, yes, you could just type in the calculator, but it's probably in your best interest to clean this up, and you could actually do this whole thing without a calculator. So maybe pause here if you want and see if you can figure out what this whole thing reduces to without the calculator and come back when you're ready. Okay, we know we're supposed to keep the base and keep the base and subtract the powers when we have this division. So when you do that very carefully, you get 10 to the positive 4 here. And there's a 10 in the front there, and then log of 10 to the 4, I'll put a times symbol here, but log of 10 to the 4 is an easy number. It's one of our nice properties of logs. Log and 10 are opposites of each other and they cancel. We'll see that pretty clearly in a couple of classes when we talk about inverses, but we've seen this formula before. It's just 4. So 40 decibels is the rating of the mosquito's buzz. Number 2, a large orchestra in concert produces sound with a loudness of about 98 decibels. What would the intensity of the orchestra's music be? Okay, same idea, but in this case, you're given the number of decibels. So let's put 98 on the left-hand side here. The formula is 10 log of the intensity over always 10 to the minus 16. And we're just trying to solve this for I. So we'll divide both sides by 10 to get the log by itself. Okay, and then we can use the definition. This means 10 to the 9.8 is equal to I over 10 to the minus 16. We can multiply both sides by 10 to the minus 16. And we've got our I. We'll keep the base and add the powers here. So what is this? 10 to the minus 6.2. And we can estimate this from the calculator. And whatever we get, this will be the intensity of the sound made by the orchestra. So about 6.3 times 10 to the minus 7. Doesn't seem like much. 10 to the minus 7 is very close to 0, but if you look back at the mosquito buzzing, the intensity of the mosquito was 10 to the minus 12, much closer to 0. 10 to the minus 7 apparently is about how loud an orchestra is. Number 3, how many times more intense is the orchestra sound than the mosquito's buzz? So how many times, that tells me I'm going to be dividing, and more intense, that tells me I'm dividing the intensities. So we're going to take the big intensity, the loud one, which is the orchestra, put it on top. 6.3 times 10 to the minus 7 watts per square centimeter divided by the mosquito, which up above was given as 10 to the minus 12. Keep the base, subtract the powers very carefully. We get 6.3 times 10 to the 5, 63,000. What did I do wrong there? What I did wrong is a bunch of things. Let's see. So it should have been 6.3 times 10 to the 5. And I wrote 63,000, but that's actually 630,000. Okay, that's more like it. So that's the number of times more intense the orchestra sound is than the mosquito's buzz. How many orders of magnitude more intense is the orchestra sound than the mosquito's buzz? Now, there's a hint, but let's forget the hint for just a second. So how many orders of magnitude? Well, let's see. We're looking for the number of orders of magnitude in this number. So this number right here was 6.3 times 10 to the 5th. So the answer is going to be, something around 5, right? This is approximately 5 orders of magnitude. It's bigger because it's not just 10 to the 5th, but it's 6 times 10 to the 5th. So the number of orders of magnitude is just the power of 10. How many more powers of 10 does the one number have than the other? It's approximately 5, but it's a little more than 5. But we can find out exactly what it is by using the hint in the parentheses. Remember that the number of orders of magnitude by which two quantities differ is equal to the common log of the ratio of the two quantities. So we saw that in the class notes. It is a mouthful, but all we have to do is take the log of the ratio. And so we can type this into the calculator. We've already done the division part. It's up here. It says 630,000. So what do we get here? Log. In fact, maybe I should, what should I do? What if I take this guy and divide it by 10 to the minus 12? So it's really closer to 631,000. Maybe we can make that adjustment here. Okay, so we're typing this thing into the calculator to get the number of orders of magnitude that these two things differ by. Okay, so log of that crazy number right there. And we should get something around 5.8. So a little more than 5, that seems reasonable. Okay, moving on to number 5 on the next page. What's the difference between the decibel ratings of the Mosquito and the Orchestra? Okay, the decibel rating for the Orchestra was given as 98. Subtract the decibel rating for the Mosquito was also given, that was 40. So these two things differ by 58 decibels. Okay, and now things get really hairy. Number 6, how are your answers to 3, 4, and 5 related? Okay, let's go back. Number 3 was in purple, it's that ratio. Number 4 was the log of that ratio. So we can at least write that. 4 is the log of 3. Okay, so far so good. What about relating these things to 5? It didn't seem to come into play at all. Let's see, so the number of decibels, the difference between the decibel ratings. All right, let's see. 58, does that number look at all familiar? 58, what was our answer down here? Was 5.8. 58 is exactly 10 times 5.8. Why is it 10 times the 5.8? Well, let's see. In the definition of logs, there is a 10 sitting right there in the front. So there's a 10 times happening. So if we take 10 times the log of 1, or 10 times the log, and it gets you the decibel rating. So I guess technically, we're not looking at a number of decibels there at 5.8, but it sure looks like the number of decibels if only it had a 10 sitting in the front. So it feels like the answer to 5 is 10 times the answer to 4. Let's write that. I warned you this would get hairy. Answer to 5 is 10 times answer to 4. Putting those two red sentences together, we see that answer to 5 related to the answer to 3. Answer to the 5 is 10 times the common log of 3. Really take your time to process and digest and do these examples a few different times. This is not easy. Number 7. Complete the following sentence. The difference between two sounds' decibel ratings is equal to blank times the common log of the ratio of their intensities. Difference between decibel ratings is blank times the common log. Well, actually, I think we just wrote that, didn't we? The difference between the decibel ratings here was 58. What did that have to do with the common log of the ratio of their intensities? Well, that ratio in this problem was 5.8. So 58 getting to 5.8 was just 10 times. So in this case, because it's decibels, and there's a 10 in the front in that formula, it's always 10 times. 8. If the orchestra's sound doubled in intensity, what would its decibel rating be? Hint, the ratio of the intensities is 2, so they differ by log 2 orders of magnitude. Okay, so there's the more straightforward way, and then there's the more advanced way. We'll start with the more straightforward way. The orchestra sound is going to double in intensity. So let's actually go back. What was the orchestra's sound to start with? Let's see, it had a loudness of 98 decibels, and down here we found the intensity was that. So we're going to double that, and we're going to figure out what the new number of decibels is. So we're 6.31 times 10 to the minus 7. So we're going to double 6.31 times 10 to the minus 7. So we're going to calculate the number of decibels in the new sound, the louder sound. 10 log of the intensity, always divide by 10 to the minus 16. That's our reference sound. And what's the intensity? It is double the 6.31. 12.62 times 10 to the minus 7. Okay, so this is pretty straightforward. We're just going to crunch through this on the calculator. It's the straightforward way, but it's certainly not the elegant way. So let's bring this up. And we're going to type all this stuff in. So we go 10 log of 12.62 times 10 to the negative 7. That's divided by 10 to the negative 16. And whatever we get here will be the number of decibels of the louder orchestra, about 101. Okay, so that's the straightforward kind of work way to do it. But if you got a good grasp of what we covered up above, then there's an easier way. So here's number 7 again, the difference between two sounds' decibel ratings. And that's interesting to me because we knew the original decibel rating of the orchestra. It was 98. So if we could find out how much more this one is, the double one is, then we could just add to 98. So it says the difference between decibel ratings is 10 times the common log of the ratio of their intensities. 10 times the common log, the ratio of their intensities. All right, I think that's where this hint is coming in. So the two number of decibel ratings, they differ by, so let's write down number of decibels, differs by, according to number 7, 10 times the common log of the ratio of their intensities. But the ratio of the intensities is 2. That's this hint here, because the one sound is double the other. So if we called the original sound of the orchestra I, not I sub 0, but just some generic I, then the doubling one is 2I. That's the louder one. So this is equal to 10 log of 2. And so if we type that into the calculator, 10 log of 2 is 3.01. And so if you take the original 98 decibels and you add this new 3.01 decibels, you get 101.01, which is exactly what we got before. Not easy. Number 9. What would the decibel rating of the sound produced by 500 mosquitoes be? Assume that the sound is 500 times more intense than the sound of one mosquito. All right, what if we try doing this the nice way? If we can use this result in number 7. It says the difference between two sounds' decibel ratings going from one mosquito, which we know is a decibel rating of 40, to 500 mosquitoes, which we're trying to find, says it's always 10 times the common log of the ratio of their intensities. Okay. So just like we wrote up there in blue, we'll write it again down here for the mosquitoes. Number of decibels differs by 10 times the log of the ratio of their intensities. So one mosquito we'll just call I. Now we've got 500 mosquitoes, 500 I. So that's equal to 10 log of 500. So we'll type that in. Whatever we get, that's the difference in the decibel ratings of one mosquito compared to 500 mosquitoes. So 10 log of 500. It's about 27. So then we can take the old decibel rating for one mosquito, ramp it up, add 27 decibels because we got 500 times the intensity, and we get 67 decibels for that swarm of mosquitoes. As promised, this is a very challenging activity with very high-powered ideas in it. So work through, deal with the frustration. I know that there is some, and see if you can keep pushing through this. Do these problems a couple of times. Hopefully, you'll start to make some connections here, and working with logs will become a little bit easier for you each time you make those connections.